Dear students, in this video I am going to take the examples. So examples, so three examples. So first one is summation of n from 1 to infinite, 1 into 3 into 5 into 2n minus 1 divided by 2 into 4 into 6 into 2n 1 by n. Fine. So now first we will discuss this example. So un is this 1 into 3 into 5 into 2n minus 1 divided by 2 into 4 into 6 into 2n into 1 by n. Similarly, un plus 1 will be this. So since when you put n equal to n plus 1, so last term will be 2n plus 1. So 2n plus 1 divided by from here 2n plus 2, and this will be 1 plus n plus 1. Now divide this. So remember one thing, हम सभी सबसे पहले रेशो टेस्ट लगाएंगे. कभी भी रेबीज टेस्ट डायरेक्ट नहीं लगेगा. जब रेशो टेस्ट फेल हो जाएगा तभी रेबीज टेस्ट लगेगा. फाइन, रिमेंबर दिस थिंग. So first we will find out this ratio. So when we apply the limit and tending, we will see that ratio test fails. Then we can apply the rabies test. Fine. So in rabies test, take this difference, you take this ratio un upon un plus 1, subtract 1 and then multiply by n. This will be the rabies test. So un upon un plus 1 we have already evaluated this. 2n plus 2 divided by 2n plus 1 into n plus 1 by n. So we have substituted here minus 1. After simplification we get this 3n plus 2 divided by 2n plus 1. That means 3 plus 2 by n divided by 2 plus 1 by n. Fine. So now apply the limit. This is 3 by 2 greater than 1. That's why series converges. So this is the procedure. Now the second. So un is already given to you. In the second, 1 into 3 into 5 into 2n minus 1 divided by 2 into 4 into 6 into 2n. So just replace n by n plus 1. So we get un plus 1 here. Now find out the ratio. So ratio will be this. Ratio is this. When you apply the limit, we get 1. That's why ratio test fails. Now apply rabies test. So un upon un plus 1 minus 1 multiply by n. So n into un upon un plus 1 we have already evaluated. 2n plus 2 divided by 2n plus 1 minus 1. So after simplification we get this 1 upon 2 into 1 upon 2 plus 1 by n. Apply the limit, which is half, so less than 1. So rabies test pass and the series is a divergent series because this is less than 1. Fine. Now the last example, un is this. Multiply by x raised to the power 2n plus 1 divided by 2n plus 1. So obviously since x is involved, so obviously we are having cases. So un plus 1 is this. Just take the ratio. So we get this value. Now apply the limit. So after applying the limit, the value is 1 by x square. So now depending upon the 1 upon x, if this is greater than 1, series converges. If this is less than 1, series diverges. And if this value is 1 upon x square is 1, test fails. So now by the ratio test, this series converges if 1 by x square is greater than 1. That means x is less than 1 because x is already a positive value. Fine. So obviously x square is less than 1, only possible when x is less than 1. Fine. So this is the way. Now series diverges if 1 by x square is less than 1. That means x is greater than 1. Now the test fail when x square is equals to 1. So put x square is equal to 1 in the function here. So what we will get? You will get only this part, multiply by 1 by 2 plus 2n plus 1. So we get this un upon un plus 1. Apply the test. So test fails. So test fails. So that's why now we will apply the find out the un upon un plus 1. So un upon un plus 1 is this ratio. Fine. Now multiply by this n. So after simplification we will see that n into this is equal to 3 by 2, which is greater than 1. So by rabies test un converges because here first we have applied the ratio test. When ratio test fails, then we have to apply the rabies test. So this is the rabies test, this is the ratio test. Fine. So rabies test applies and according to the rabies test we get 3 by 2 limit, which is greater than 1. So according to rabies test, series converges when x equal to 1. So this is the conclusion. Series converges when x is less than equal to 1 and diverges when x is greater than 1. Fine. Now in the next class we will see about the logarithmic test, De Morgan's test. Fine. Thank you.